In today's video, we're going to be looking at my favorite LEGO set of all time, the Lego DACTA 9701 Control Lab building set. It was released in 1993, included 527 pieces, and instructions for 8 models. So why is it my favorite set? I think it's just because the possibilities are so endless. This set came with tons of motors, gears, pulleys, sensors, and at the heart of it all, the Control Lab serial interface and the Control Lab software. You can create custom control pages to control your LEGO creations from a computer, which is just the coolest thing to me. I drooled over these catalogs as a kid because I wanted this so bad, but I would just dream in my head about what I could build if I had all this at my fingertips. In recent years, I found a lot of this stuff on eBay and started building my own creations. I've controlled LEGO switch tracks on large LEGO train layouts, controlled the lights on my spaceship hangar, an entire monorail layout, and the GBC Control Center, which had a ton of awesome features. The scripting is done through LEGO Logo, which is the brainchild of Seymour Papert. It's based on the Logo programming language, which was created by Wally Fierzig, Seymour Papert, and Cynthia Solomon. If you want to learn more about Logo, I would recommend watching Macintosh Historian's video on the subject. It was really interesting to learn about, and she's just a delight. Okay, this is my friend Miss Fox. Well, she's not quite my friend. I did send her an email one time. She's going to tell you all about the history of the Logo programming language. So you're going to be nice, you're going to pay attention. So to start off, we're going to look at these sets and the packaging that they came in, the instructions and curriculum. Then we'll give a quick introduction to the software itself, and then take a look at some of the builds in action. So without further ado, let's get into it. Okay, so before we dive into the actual sets themselves, I did want to show a catalog entry. This is a Pitsco Lego DACTA catalog from 1999. And this is the Control Lab set. So if you just wanted the building set itself, it would have set you back $256. The software was an additional $92. The curriculum pack, another $83.50. Then you also need the serial interface and adapter, which is another $250. So I guess, you know, most schools probably would have just got the starter pack for $695. And it includes all of the things we've already mentioned. If you want to take a closer look at this catalog, along with many more, I've got some links in the description where you can flip through these on archive.org. So let's go ahead and open it up. This box, I wish I had a better box. It's a little caved in from having stuff stacked on it. It's got some pencil holes and stuff. It's a little rough. But everything inside looks pretty good. So we've got some literature here. We're actually going to go through that in just a second. First, let's just look at the pieces and how everything's organized. And this is what I love about Lego DACTA. Just everything is so neatly organized inside of here. Actually, let's go ahead and pull this. So I guess this only would have come in this version because it's got, you know, a picture of that box. And inside here, it actually tells you how to organize all of the pieces inside of there, which is pretty cool if you ask me. So yeah, if you can look at the pieces, it's pretty much kind of standard Technic and system pieces from that era. Of course, we've got our sensors here. So these are different, a different touch sensor than what you'd see in an RCX set. But the other sensors are pretty much the same, except they generally had longer cables attached to them. I'm missing 2 rotation sensors here. I have them somewhere. I've got some models built. We've got the chain link elements that you can make like a conveyor belt with, or a tank or something like that. I remember seeing these in the catalogs, and I would see these sets in particular and be like, God, I wanted a bunch of these to make a bunch of conveyor belts. So I guess I have 2 sets of them because I've got all the loose pieces here. So that's probably all it would have come with. You've got a bunch of just standard wires and different lengths. So some of these are pretty short. Some of them are fairly long. And thankfully, I was able to get a good bit of these wires that have this style of insulation. Because many of them use the rubber insulation that just flakes off and degrades over time. So definitely something to look out for. These are very interesting. These are actually used to help organize the cables. This is cable management, and this just kind of wraps around the wire. We will show these in use later in the video. Of course, you've got like these, or not rare, but they are expensive nowadays because they're used in Lego GBC. There's actually a very good BrickNerd article that's all about this piece. I actually sent a video over that was used in that. So let's go ahead and put this up, and then we'll go to the next one. So this is the other style of packaging. This is very common. A lot of sets would just come in both style packaging. So if we take off the top here, we've got our cover card, I guess, which is very nice. On the back, it actually has where all the pieces go inside of here. And then we've got, this is half the pieces, or maybe not exactly half, but we've got our 3 motors here. And of course, you know, we've got a card underneath that tells us where everything goes. I don't know if this is, yeah, so this is actually just another cover card. I don't know if it had a separate one that just had this, or if you only got one when you bought it. I'm doing my best to piece all this stuff together after the fact. It's not like I bought these complete like this. So we've got all the same pieces that were in the other set. You know, over here we've got our lamps and our sound sensor, or sound element, and then our sensors here. And again, everything just neatly organized. I don't know, you know, out of the two, I don't know which packaging I would prefer. But it's just really cool that they went that extra mile. So this one does not have a cover card. And we've got all our wires in here, big turntable. And then, of course, we've got our card down here. And then I think, yeah, the back of this, I think, is just white. And that tells us where all the pieces go. So I think that's pretty cool. Now let's get into some of the literature. So again, we've already kind of shown the beginning of this, where all the pieces go. We've got some building tips and techniques. So some cool stuff here. I love when they include these extras like this. I think that's pretty cool. You can see there we've got the little cable management. I don't know what you'd call them. But yeah, and we've got some builds here. So yeah, we've got some lamps and a temperature sensor and then a fan. So I guess the lights would heat it up and the fan would cool it down. I guess that's kind of like a CD player or something almost. Like, I don't know what that is, because that's not in any of the other literature that came with this set. Maybe it was a model that they didn't end up including. But it's cool to see here. This looks like an alternate robotic arm. This one's actually much more advanced, using 3 motors. But again, that's not in this. We have a kind of remote control plotter robot. That's not included. Yeah, I don't think any of these are. You know, we've got a red light, nice little T intersection there. That's pretty cool. And then this looks like it's supposed to be like a barcode reader, something like that. You know, the light sensor would kind of read the different colors coming through. And then, you know, it could be like a security card, and then it would light up red or green, whether it lets you in or not. And then this is actually combining 2 of the models. There is a conveyor belt model and there is a robotic arm model. So that'd be something fun to do too, but won't be in this video. We've got our 9701 directions for use, and it's only so thick because it's it's in a lot of different languages. It's really only a few pages, but it has some interesting stuff in here. Hopefully I'll have this archived by the time this video goes up. Yeah, we've even got some technical references here, so that's pretty great. And then it just keeps going into the different languages. And then, you know, we've got this nice front and back cover. This stuff is just like, it's so nice to look at. Like, I just like all the primary colors and everything. So we've seen that, and that's the greenhouse, which we'll get to. These are more of the models that we saw on that other page. Actually, I would think maybe these 2 came with the plastic bins, and then this is the one that came with the cardboard box. That's probably what it is. Because yeah, this is just front and back, the same models we were looking at earlier. Our building tips and techniques. So yeah, now we have the instructions to all the builds. We're only going to cover a couple of these today, and I'll explain why. So we have the greenhouse with a temperature sensor inside, so if it gets too hot, it can open up the side door. You can also add a fan as a kind of an add-on. It will tell you here what special elements are included. So we got a rotation sensor to see when the door is all the way open. It tells the motor to stop running. The temperature sensor, of course. A sound element, and I think that's supposed to be like an alarm if it's opening or closing, just so people get out of the way, because you wouldn't want to get any minifigures hurt. And yeah, they're fairly typical 90s instructions. Like, you're actually putting down a fair bit of brick and tiles. Not like the instructions of today where it's, you know, a page or two for like a couple pieces. These, I believe, are archived. If I might have to upload my own because I might have better scans. And if I put them on archive.org, you won't be slammed with a bunch of ads. That's a real problem in the Lego instructions world. I've tried to look at instructions and had half the instructions covered up by ads. This is a candy machine, and this is one I've never built, and it is one I want to build soon. So what I might do for these other models is upload independent videos of each of them, because they're going to take a little time to figure out, because there's no curriculum. There's nothing to go by to see how exactly it was programmed. Yeah, we got the building instructions, sure. But I'm kind of on my own after that. And some of these do look a little bit challenging. So I think that's going to be a fun one to build one day. This is the Dynamometer. And this one we do have built today. And yeah, that's a real car on a dynamometer, I guess. And we're just kind of measuring the RPM. And it also has kind of it's testing the headlights. We'll get into it later. But yeah, same kind of thing. With the instructions, it's even telling us where to plug in each device. So like the motor is going to go to port D on our outputs on the DACTA control lab. This is a motorized wheelchair with joystick. I haven't built this one. This one actually, I'm not exactly sure how I would program it, so I'd have to learn how. But I think that could be pretty fun. And I love that they always have the real world pictures to go along with it, like to show what you're building. Uh-oh, this one's... I'm slipping. I'm to try to keep the stuff in good condition. But yeah, that's that. This, I believe, is supposed to be a scanner, because if we look at... That looks like a scanner to me. It's not printing. It's actually just got a light sensor there. And it's just reading, I guess, the letter A in this case. This is another one I wouldn't really know how to begin programming, but maybe one day we'll look at it. This next one is a conveyor belt, and it looks like we've got a light sensor there, so maybe I don't know, I have to look at this more in depth. Like maybe if it's one color it does one thing, and if it's another color it does another thing. I'm not really sure. Again, it's not one I've built, and it's not going to be covered today, but I always love a good conveyor belt. That was definitely one of the things that stood out in these catalogs when I was a kid. Then we've got the robotic arm, and this will be covered today. We're going to have local and remote deliveries, and they'll get separated into each bin. And then we got this thing. This looks more like a drill press than it does a robotic arm, but I'll let them, you know, I'll take their word for it. So yeah, that's the instructions. We do have one more box here. So this is the DACTA control lab, and this is how it would have come on its own. Part number 9751. And I love the box that it has this full color image. I think that's pretty cool. I think this would be complete. This would be everything that would come in it. So let me just take it out so these flaps don't get in the way. So we have our transformer. And this is the same transformer that was used for so many of the Lego electronics. You could use it with the Technic Control Center 2, with your 9-volt regulator for your trains, and many others. I mean, the RTX, even the rechargeable NXT, one of those batteries could use this. So that came with it. We have our DACTA control lab. 8 inputs. These are passive inputs, and these are active inputs. So this is touch and temperature, so it's just a resistive feedback. And then the active sensors for rotation and light, it actually powers this port for, a fraction of a second, and then takes a reading and then goes back to powering it. So that's why these are active sensors. It's kind of ingenious. We have our 8 outputs. So we've got A through H, 9-volt outputs. I believe there's 8 speed steps that you can control in this. So it's not just on or off. And then of course you can go in either direction. We have an emergency stop button, which is I've actually used. And then we have this port down here is just a test port. You can just plug in a motor and test it, and it's always powered. And then we have the kind of user guide and everything. This folds out. So these are the same images we've kind of seen elsewhere. And we've got our nice little diagram there. Very good. Yeah, this is important, and this is printed on its own. This is probably something they figured out later, and it's like, oh god, we have to include that to make sure you don't hook an output to a sensor port, an output to an output, or an output to the always on, or of course the always on to the sensors as well. So yeah, very good warning. Glad they added that. And then we've got our directions for use. There's a bunch of these in here, but they're all just, some of these are in completely different languages. So we'll just look at the English version for now. We speak English. I do, at least. I don't know about you. So let's open it up. And yeah, we've just got a lot of little information about getting set up, what the errors mean. I have definitely had to do some troubleshooting with these. We've got our port on the back. Yeah, it only uses 3 pins, receive, transmit, and ground. And that's actually comes in handy for some of my other projects when I'm hooking to these. Current output, so 320 milliamps per output. But there's probably an upper limit too for the entire thing, which I'm not. Yeah, total current 640, so it's not really that much. That's about it there. Be careful with other chemicals. Yep, we will do that. We will be careful. And next we're going to get into the curriculum that came with it. I'm actually missing one of these. It's got to be around here somewhere. But for now, I've got to turn my phone off for a bit and let it cool down. And then we'll get back to these. Okay, so now we're going to go through some of the curriculum here. I'm not going to spend a ton of time with this. That's probably the most boring part to some people, but we'll get through it quick. And again, you can find these in their entirety on archive.org, linked below. So we'll start with the setup guide and introductory explorations. This one and then the quick start guide, they actually cover some of the same things. That's the one I can't find at the moment. It's around here somewhere. But yeah, it's just kind of getting set up, plugging in your cables, just simple kind of stuff like that. And then towards the back, I think, yeah, we run a few commands and kind of learn how the sensors and the outputs and everything interact with the software. We are going to run some of those commands, but I'm not going to go through it step by step like it's outlined here. That would just take far too much time. This video is going to be long enough as it is. This is the reference guide. So if you ever want to use this software, this is what you need. This is, every command that's used, and just there's a ton of information. This shows you how powerful the software was, to have this much information on how to use it. It's just incredible to me. So we're done with that. All right, so this is the kind of main book here. This is the Technology, Investigations, and Inventions. And yeah, so this is their kind of flow chart here. If you're familiar with computers, you can just go to this quick start guide. Otherwise, go to the setup guide. And if you're familiar with Lego DACTA computer control, you can kind of skip. Or you can, if it's a no to both, you go through all of them. And it goes through a bunch of teacher type things, like which projects kind of teach what things, whatever, teacher stuff. So let's see here. Let's go ahead and go. I don't think there's anything. Yeah. Let's go to the greenhouse project. And these are pretty in depth, these first 3 at least. I mean, it just really goes into detail. What is a greenhouse? How does it work? The greenhouse effect. And it just keeps going. So yeah, it even creates like a real world kind of scenario here that the students want to start selling flowers, and the ones they want to grow, they need a greenhouse for. And so we set about to build one. And yeah, these first three, they're very in-depth. Skipped a page. So there's your greenhouse. And then, you know, it goes in depth into the making the programs and everything, step by step. We're going to show off these exact programs once we get to those. So that's really cool. Now we have they just call it a robot, but it's, you know, a robotic arm. And the scenario they set up for this is that you're at a homemade ice cream company. And we need to separate our remote and local packages, or I guess they say distant, local and distant packages. They need to go down a different conveyor belt or be stored somewhere else. So we need an arm to be able to do that. So that's the arm we build. And then we go through and build some programs. And for this one, as well as the greenhouse, you start with a very simple control panel where you could just control it manually. And then you just keep going and you actually make a program that's a little more automated. So if a local package comes down, you just hit the local button, it'll move it to that bin, and then it'll count how many packages there. So it's really cool how it kind of, you know, steps you through in the complexity of it. You know, you can just make a control panel and control it yourself and then automate it. So it's really laid out well in order to really drive home these principles. Now we're building the dynamometer. And you actually start by building this kind of test bed here. And you kind of learn the basics of it first before you actually build the dynamometer. So we'll be showing that in a little bit here. And again, walks you through all the software and everything to build your control panels and get going. After that, okay, so this is the color code reader, and we've seen pictures of it, but there are no instructions. I think it lays that out in here. I don't remember. I know it does for the bridge. Yeah, let's see. Maybe we'll look at the bridge for a better example, but it doesn't kind of hold your hand like the others. Like, you're supposed to just build it yourself. And at least this one gives a little information on programming. And then, yeah, this is the bridge. And it literally says, students can build a model similar to the one shown below, or they can design and build their own bridge. So it is an invention, and it has no step-by-step instructions. But honestly, from these pictures, you know, they've got these different views. I think you could probably build it pretty easily. I probably will. I want to build that one day. Not in this video, but that's something I might get to eventually. And then it's got some, it does kind of go through some of the programming of it. But that's basically it. It does have some stuff in the back. This stuff might be pretty interesting to somebody, but anyways, that's kind of my point, is that some of the instructions that come with the set, there's just no information for in the book. Like the electric wheelchair. There's just nothing to go on. So if I ever build that, I've got the instructions, but I'm on my own when it comes to programming it. So from here, let's check out the Lego DACTA Control Lab software. All right, so we're going to take a quick look at the Control Lab software, just some of the very basics. And this is mostly going to be from the Quick Start Guide, Creating a Fan Control Project, which is the book I'm missing. So this is the simple little fan that we build. We're going to hook up the fan to port A, and then we're going to hook a touch sensor to port 1. And we'll just kind of show how things work. So let's go back to here. We need to put a motor onto port A. We're already plugged in here, so we've got our DACTA Control Lab. This is a USB to serial adapter, and then I've got a little null modem adapter in there as well, because it did require a null modem cable. This computer is certainly not period accurate. This is the Windows 95 version of the software. Of course, it was on Macintosh and a few other options back in the day. This software should run on just about any 32-bit version of Windows. This is Windows 7, and it still works just fine. It is a 16-bit piece of software. So I have tested 95, 98, XP, and Windows 7. As long as it's 32-bit, it does seem to work. Although I have heard some folks in the comments say Windows 2000 was a no-go. Not sure why. So this is our fan. We've just got a little base plate here. We've got a belt that drives it, and it's gears it up a little bit because we got the smaller pulley up here. These are the rotor blades from, they had maybe helicopter sets, or like I think they had some boats that use these, like airboats. But they actually it does move a little bit of air. So let's just quickly, just to test it and make sure it runs, if we can click on these little circles up here. So those are the two directions. So let me hold it there. Yeah, we got a nice little fan. I can feel it blowing on my hand pretty good. Now all the programming is going to be done in Lego Logo. So we can actually test commands with this little box down here. So I've got some notes here. Let's copy this command. And then what this will do, talk to is how you talk to your outputs. Motor A on, and then it's going to wait 40, and 40 is deciseconds. I think that's how you say that. So that's going to be 4 seconds, and then it will turn off. So all you have to do is press enter. 1, 2, 3, 4, and there we go. We can now type CC, and that will clear the command box. But sometimes commands can still be running in the background. I'll show that in a bit. We can go ahead and integrate our touch sensor now. So we need to hook that up. So I've just got my touch sensor here. Again, this is different from the RCX touch sensor. It's a little different form factor, and it's got the cable attached to it. But let's go ahead and hook that to port 1. And if I press it, you can see it lights up on the DACTA Control Lab. So now we've got a command here. Wait until touch 1. So that means when it's pressed, it will be not touch if it's not being pressed. And then we're going to talk to motor A on for 4 seconds. So let's go ahead and hit enter. Oh, okay, yep. I need to add the touch sensor to port 1. And actually, yeah, if I touch it, yeah, true, false, true, false. So let's go ahead and let's take this out and go ahead and run this command again. And you can see it's kind of waiting. It's got that little icon there. And if we press the touch sensor, it should run for 4 seconds and then turn back off. And then after that, it doesn't do anything. So if we want to have a more, a program that's actually going to run in the background, we're actually going to use 2 commands here, and we're going to use the forever command and the if command. So it's going to do it forever. If touch 1, turn motor A on. The focus is not doing so great here. Hopefully this comes out okay. So now if we press the touch sensor, it will turn on, and it's just going to stay on this time. So we can actually show the emergency stop. Very handy if you've got like a robotic arm going out of control. And then you can press it again and keep going. And then we can type all off, and that will turn off all of the outputs. Now let's go ahead and add one more command. Let's Control V. Okay, forever, if not touch, turn motor A off. So hopefully I've done this right. Yeah. So as long as we hold down the touch sensor, the motor is going to be running. And you can hear the motor start to slow down over time. That's just the DACTA Control Lab. It's a little funky. I don't know why it does that. But that is that. So let's go ahead and I'm going to create a new program actually. Just because I want to clear out those commands that we've run. in the background. So let's go ahead and put our touch sensor back on port 1, motor on port A. We can test it. We're good. Let's go to here, and we're going to actually create a script or procedure, as they're called here. Okay, so 2 is just saying it's a procedure, I guess. Wait until touch 1, talk to motor A on for 2 seconds, and then end. So that is our procedure. And we can go into our command center here. I believe if I just type fan, it says it's running. So this procedure should just run forever now. So if we press it, 1, 2. Come on. Really? Maybe I was mistaken. Let's try this. Forever fan. One, 2. Oh, okay. Yeah, forever needs more inputs. There's definitely a way to do it. I haven't used this software in so long. It's just been a little while. And then also, of course, we've got all kinds of things. We've got, you can create graphs, and this will plot your sensor readings in real time. It's amazing, amazing software. We can add text, of course. We can add images if you wanted to. Let's go to properties, empty picture. Yeah, picture of a touch sensor. There you go. And I've definitely shown this in more detail in an older video about this software. This is another sensor reading monitor. And I'm just going to add a button. So it's a big old button, button 1. And then let's say it is on off. So if it's on, TTO is an abbreviation of talk to. Motor A on. Oh, shoot. Okay, much easier to type when I put the phone down. So when it's on, it's going to turn the motor on, and when it's off, it's going to turn the motor off. There's a lot of different, you can use different button styles. You've got just a ton of them. Is there anything interesting here? We'll just use a big old button. That's satisfying, isn't it? So now whenever we press the button, and you can see it's held in, it's going to run the motor. And then we can turn it back off, just like that. We can also go in and say it is an on button. And then it's just however long we hold down the button is how long the motor will run for. So there's a lot more to go with this software, and I don't think I've scratched the surface in learning all of that it's capable to do. But I think it's really cool to be able to build control panels with graphs and readings and all that stuff. It's just amazing. So now that we know the basics, let's look at the greenhouse project. Okay, so we've got our greenhouse all set up. We've got our fan from earlier. That's kind of an add-on to this. We have our program loaded up, and we've got a few different pages we're going to go through, but we'll start with page 1, which is the manual control. So we have a sensor reading here, 24 degrees Celsius, and we have an open and close button for the door. Over here, so yeah, we've got our temperature sensor on port 1, an angle sensor on port 6, and that's this blue guy right here. So that measures the rotation angle of the axle going through it and tells us when the door is open or closed. We have our 2 motors here. So motor A is the fan again. Port B is going to be the motor that opens and closes the door. We have a sound element on port E. So that's this little guy there. It just plays little simple sounds. Then we're all plugged in here. These labels are not official Lego. They just really come in handy for this kind of stuff. I've shown them on the channel before, but they're just some cheap Amazon tiles with numbers and letters written on them. So it makes it super easy when you got a mess of wires coming out of something to be able to just plug them in wherever they go. Again, we have our cable management here. It's hard to show with one hand, but yeah, you just kind of have to wrap it around it. You just kind of peel it away. I can't do this one-handed, and just kind of keep spiraling it around until it holds all your wires nice and neatly. So that's pretty cool. So yeah, now we're at 25 degrees Celsius. So maybe we're a little hot. Let's go ahead and open the door. So we'll just hold down the open button, and it'll open up the side door. And if the temperature were to go back to a more reasonable temperature, we can just hold down close, and we'll close the door. And it likes to get caught right there. You just kind of gotta, there we go, we're good. So that's the simple, manually controlled version. I like how they did this. You start with page 1 and you just set it up manually to make sure everything works. So let's go ahead and open page 2. And then this is the automatic greenhouse system. This temperature, it's kind of funny when you open a program, sometimes you have to reactivate it. There we go. So 25 degrees. So if it's over 24, it should open. And if it's under 22, it will close. So that's not super great for what we're trying to do here. It's probably never going to get below that in the heat in Florida. And I've got the AC off while I'm filming, so it's actually 77 Fahrenheit in here right now. So we'll go ahead and we'll kind of skip over this, but I will show you the procedure page here. So yeah, we've got our if temp over 22, and this isn't going to focus, is it? There we go, that's a little better. So we have 2 open vent, that's a procedure to open it, and then end is the end of it. Then we've got same thing for close vent. And then up top here, we have the greenhouse procedure. So if you hit that system button, that's what turns the system on. And then forever, if the temperature is under, it'll close. If it's over, it'll open. So it's a very simple little procedure. Let's open up our page 3. And this is where it gets a little more advanced. We're basically just adding the graph here. So this blue line is actually the rotation sensor. So if it's open or closed, it will be, one of these 2 values, either 0 or 15. And then we've got our temperature reading over time here. And the way you figure out this rotation angle is pretty cool. There's actually a few different ways to do it. But if we double click on motor B and click on experiment, we can compare it with something. So we can either do a stopwatch, or in this case, angle 6, an angle sensor. And then we can, let's see which way is which. That's closing, so that's not going to do much. And if I click that, it will reset it to 0. So if I open, yeah, so that's usually what I go to, about 15. That's how far it opens. And then that'll tell the motor to stop if it's running in automatic mode. And then we can go ahead and close it back. And it should basically go to 0. It's kind of catching on that thing there. So I've actually, if I remember correctly, greenhouse BPB, no save changes. I don't remember what that error is, but it's probably just because I opened it. So we can actually click down here to reset the graph. So now it's going to go ahead and read. I'm going to get, my microphone cable keeps getting caught up in the motor here. So let's turn on system. So it's going to play that sound alert as it's opening. Because we're already over temp. So that's the issue here. So we got the door open, fan turns on, and that helps to cool off things inside of there. And that's probably about as far as we're gonna get, unfortunately. I should have changed it to Fahrenheit, and then we'd be dealing with smaller increments with the temperature, because it's just never really gonna get below, what is it set to here, 23 degrees Celsius. Yeah, we're probably not gonna hit that even with the fan running. But if you had a little more time, if you set this up in a window and maybe even had a little plant inside. Actually, when I set up to film this 3-4 years ago, I actually had a small little plant inside of there, but didn't worry with it this time. I gotta get this video out. I've been wanting to do this for years. So I think that's about it for the greenhouse. I think the other projects are a little more involved, a little more interesting. You can kind of play with it more. So we'll go ahead and move on from here. All right, we're all set up with the robotic arm. So we have a motor down here that controls the rotation of the arm. And then we have a motor here, which opens and closes the grabber. And a rotation sensor, which tells the DACTA control lab, where the arm is in its rotation. And then we have a simple program here. This program kind of sucks. I don't know why they did it this way, but this is how it's laid out in the the program. So we've got towards bin and towards boxes. So if we want to go towards the bin, we press that, and then we press it on, and then we have to click it again to make it stop. And then go back towards the boxes. Okay, hand open close. So if we click that, closed. Towards bin. So that's something. I don't know why they didn't just have, for like the rotation, why didn't you just use those buttons to control it? So let me put this back over here. I also built this little add-on so you can throw that on the back there. And that allows you to get one more box in there. Well, I want it to be open. Okay. Let's see. All right, let's get it turned around again. Something like that. And then in this case, you can control it manually. And then these little boxes here, you can update with how many you've put into each bin. Again, it's the manual version of this program. So from here, let's go to page 2. So this is the real deal right here. And then again, we can go to, which motor's which? Yeah, it's this one. If we double click this, go to experiment, and then angle 5. So we're at 0 now. And as we move the arm, oops, wrong way. You can see the rotation sensor starts to increment up and down. Oops, a little too far. That's a good starting position there. Reset. That's 0. Okay, so I guess the ones with the arrows, we'll say those are the distant packages. So all I have to do is click place distant. Whoops. Okay. The next one will be local. It's off just a little bit. It's going a little too far the other way. And you can see each time this number increments for however many you've placed. Next one's distant. Okay, so that's what happens when things go wrong. So if we go in and we look at the procedure, it's really pretty simple. The startup resets your distant and local. Those are the these numbers here. These are active fields that update with this variable quantity local. And then we've got a procedure for placing distant, a procedure for placing local, and all that. So we've got this, wait until angle 5 is less than -49. And then 60 is, that's going to be the difference between the two bins, which number it needs to go to. And then to go home, where it's going to pick up a box is just going to be 0. So it's a pretty simple build, but again, I think it's pretty fun. You can actually just kind of play with it. And like we saw in the manual earlier, we would be able to combine this. If you were in a classroom and your school has a lot of money, and they have several of these sets, you could, hook multiples together. You can have a robotic arm and a conveyor belt and, those kind of things. I've waited all these years to get to this point and get this video out. And then after that, I want to do some of the other builds and maybe just kind of build some stuff on my own. Because I have a ton of these pieces. I've bought several versions of this set. Some were just the bulk pieces. Some were, the motors and lights and then trying to get all the curriculum in the books and all that. And I think those came from Canada. But I have an entire bin of like these pieces, the red beams, the red pieces. So I could probably build something pretty cool with it. So I think we're done with the robotic arm. Let's move on to the dynamometer. All right, so now we have the dynamometer and the motorized car. So initially you build this little jig here and you kind of learn about how these two wheels interact with each other. You actually measure the circumference and all that. And you've got two rotation sensors to compare between them. But we're just going to kind of skip over all that and go right to the real thing. So we've got a motor in the car, two headlights. We have a rotation sensor here. We also have a rotation sensor here. It's in the instructions, but it isn't actually in the programming in the book. I could have set this up. I have used control levers like this before. So basically you could set the speed of the car with that, but I'm not really going to worry about it because of the way this thing works, so it doesn't make a lot of sense. So this is our control program here. Let's go ahead and knock these numbers out. So first off, we can control the headlights. So I'll just go ahead and turn those both on. And you can actually control the intensity with this little guy right here. And then we have a light sensor here, and that's the reading under the lights there. So it's at 100 now, and then you can pull this thing over, and you can kind of test both headlights, I guess. Just kind of an extra little thing they put on there, which is fine. On the back, we have a little sound element here, and it just plays a little chime before and after it runs the dyno. So what we'll do is we can set our speeds here, which again we could do with that other rotation sensor. And then we have the find RPM button, and that just runs a procedure that we'll look at in just a minute. So I'm going to click find RPM. You get a little chime. It's going to run the motor. Another little chime. So we average 337 RPMs for that run. So now let's try a different speed. So we can actually select from 4 to 8, because even 4, let's check that out. Okay, see my microphone cable keeps getting caught on everything. Find RPM. You can see how slow speed level 4 is, so anything below that probably just wouldn't do much at all. So now we've got 112 RPM. So we'll try them all. Speed 5. Speed 6. And speed 7. Okay, so those are our different readings here. 337 to begin with, 112 for the very slow, 165, 220, and 276. So it's a pretty fun little project, but really the point of all this is the things you learn. And I didn't really show that in some of the books, where you're calculating gear ratios and the circumference of the wheels and all those kind of things. You learn a lot, and then you learn a lot working in groups and all that kind of stuff. I think this is just the most fascinating way to learn, even as an adult. I love this so much. So lastly, let's look over the procedure here, which is really pretty simple. You just reset the rotation sensor there, run the motor for 60, which is 6 seconds. And then we calculate the RPM. And all these numbers here, we found out through our experimentation with the little test board. And then this is just a simple procedure here for setting the motor speed and everything. So yeah, it's a pretty fun one. And at least for now, that kind of concludes the official builds for this video. I really hope to get some of the others later on. Maybe those will be like extra credit types of videos. So yeah, that's the Dynamometer. Oh, and I didn't show this. It is a car. I mean, it, you know, kind of drives up. It's not super great. You know, very limited with the pieces, but you can kind of pretend to drive it up the ramps. Well, I hope you've enjoyed this look at the Lego DACTA Control Lab building set. Maybe it's not your favorite set, but maybe you have a little more appreciation for it now. I want to give a huge thanks to the channel members for helping keep the lights on here, for all the people out there archiving software and curriculum online. Again, the Internet Archive is a great place to host all of this. If you want to talk more about this kind of stuff, you can join us in our Discord. Thank you all for watching, and we'll see you in the next one.